All right, so let's proceed ahead with our code. Now the next thing is, again I'm going to plot a figure. Again there will be a subplot that will be the status distribution by the salary. Okay, status distribution by the salary. Okay, so what I'm going to do here is I'm creating a copy of my data. Okay, that means I don't want to hinder my initial data. I need to create a copy of my data, and that will be a temporary data. And from temporary data, I'm dropping all the null values. Okay, so temp data equal to temp underscore data will drop NA. Okay, that means I'm dropping all the null values which are available in my data set. So here the null values are only available in your salary. So all the rows, basically, if you talk about NA, drop NA means all the rows which are having null values, they will be completely eliminated from your data set. Okay, so here I have going to create a figure. I need to draw a subplot. Okay, I need to draw a subplot, and the subplot will be something like that: 1 1 1. I'm going to take 1 1 subplot 1 1 1. That means I'm going to take three columns. Okay, 1 1 1. No, in a single row there will be. Okay, so how I'm going to take? I'm going to draw KDE, that is kernel density estimation plot. Okay, KDE plot. Okay, so what does this KDE plot used to do? So see, KDE function, KD function, or it is used to plot the data against single or a univariate variable. Okay, single variable or univariate variable. That means I am not available with the bivariate variable. I am available with the univariate variable. So if I need to draw a plot related to a univariate variate variable only, I can use this kind of distribution plots. That is the KDE. Okay, so basically KDE will represent you the probability distribution of the data. Okay, as the area under the plotted curve. Area under the plotted curve. Okay, so what I'm going to do here is sns.kd data equal to temp data. So I'm going to use this temporary data. Salary, that is, this is a univariate variable. I'm going to take only one variable only. Okay, one variable only. Shading equal to true. That means I'm going to make a shade. Okay, shade is there. Ax equal to ax. Okay, axis. Basically, it's an axis. Okay, this figure add subplot. Then color, two colors. I have already prepared a list. Out of them I can pick any of the color. If you haven't prepared list from your side, then you can give color from your side also. Okay, from your side also. And alpha equal to 1, this is again one of the variable or a parameter. Okay, so either you can take or whatsoever. I've taken alpha equal to 1 here as a parameter. So KDE plot, just X label I'm going to give the H font, and Y I'm going to give the H font as the salary and the density. Okay, salary and the density of your plots. So X axis they will come like salary, Y axis they will come up with the density. Okay, and H font I have already given. I have already mentioned here about the H fonts. Okay, what is the H font I have mentioned? That is your font in which you need to show your text, and what could be the weight, that is whether they are bold or whether they are not bold. Okay, so this is what I have been taken here. So X label, salary, H font, and H font. That means they will be having this text will be written in this particular format, Sharif, and it will be bold in nature. Okay, so this is what you have included in the X label and the Y label. You could also might have given title also, and you can also include the same thing in these also. You know, if you are going to work out the basic tutorials of all these libraries, you can do the variations related to the fonts and whatsoever. So there is a mention, there is already mention in these functions in your whether it is title, whether it is X label, whether it is Y label. If you are working with the matplotlib library, because this is due to matplotlib plt, this is because of the matplotlib, this is because of the cborn. The plot which has been prepared here is because of the cborn, but whatever the X labels and the Y labels has been given, this is because of the matplotlib plt we are taking. Okay, so whether you can give your title, X label, Y label, there are other various parameters also available in this function, so you can check out for what are the parameters. You can try for that. Very basic parameters, font size and all these things are been available, okay, in the tutorials. Okay, so I'm using this particular thing, and plt.show to show your graph. So this is the plot, this is your KD plot or the salary distribution plot. Okay, fine. So KD we can salary, if I just say that from 0 to 1. Okay, from 0 to 1, and here is the density. So higher density is between, for example, zero point 0.1 to point less than zero point 0.6. The density of means salary could be more here in this particular case. Then later some are having high salaries, so they came under the range of zero point 0.6 to zero point 0.8. And if few are people who are having a bit higher salary, they came under the range less than 1 and between zero point 0.8 to zero point 0.1. Okay, so here is the density. We are calculating the density of the salary figures in which they are basically available. Okay, density, kernel density estimation. As per the definition, also I've told that we are going to plot the data against a single or univariate variable. We are finding the probability distribution of the data. Probability distribution, basically. Okay, so how your data has been distributed. Okay, so you are available with the salary. Okay, some are having salary between this range to this range, so the probability distribution is more in that particular case. If you are having a salary in other zone or other distribution range, so here is the salary and here is the another is the salary. So most of the people are having some salary, some set of salaries here in this. So here you can see that there is a peak tower available. Okay, so this is what the KD means. Okay, to check out the probability distribution of the data. Okay, so probability, obviously the probability lies between 0 to 1, obviously. So here is the data of the salary is between 0 to 1. Okay, please don't have a change. So it's been between 0 to 1, and here is the density. Okay, here is the density. Okay, how much density? 6, 7, or 8. Okay, whatsoever. Here you can y-axis, it's been given. Okay, so this is KD graph.
Sir, it looks like a
Yeah.
right skewed graph,
Hmm. Right. Yes. Okay. So this is how we can check the distribution. Next, if I need to check the temporary data, salary, mode, ILOC, the first row, if I just want to print, so this is the salary. Okay. Now the thing is, next thing is, let me take data status and the salary. If I just with the data, not with the temporary data, please. This I have done with the temporary data. But now if I just prepare a new data frame with only salary and the status. Okay, and np dot is nan data dot salary, whether we are available with null values, with only null values. Okay, with only null values. Okay, data dot salary is null with only null values. If we just prepare a data set. Okay, so here you can see 67 rows, 67 row not placed, and salary is also not been mentioned here. So data salary status, that means take salary and status as these two columns. Okay, and here you need to perform the operation in such a way that you need to only have salary which is null in nature, is null. Okay, np dot is null, that means only take the salary which is null in nature. So here we can see 67 rows, null values, not placed, that's been mentioned. So let us took a correlation between the salary and your status. Just draw a correlation between these two. So data dot salary, fill na 0. For example, if it is a null value, just fill with 0. Okay, just fill it with 0, because here the option which we have seen, that not placed, these were not placed, these candidates were not placed, and obviously if they are not placed, they are not earning anything. So here null values are available. So what I did is, I just tried to find a correlation. What I did is, I filled with 0. Fill n is 0, in place equal to true. Okay, just fill null values with the 0. Okay, and then again draw a subplot. Again draw a subplot. Okay, and subplot will be like, most I'm taking 18 rows and the 4 columns. At most I'm taking 18 rows and the 4 columns. Ultimately I should have taken, let's see what happens. Okay, then I'm going to draw a scatter plot. SNS dot scatter plot. Okay, in every subplot I need to draw a scatter plot. Let's see, in scatter plot, salary on x-axis I'm taking, and status or I'm taking on y-axis. Data equal to data initially I'm taking. Okay, and color, this is what I can take, any of the color, 2 colors, 5 colors. I've already mentioned I can take any of the colors from it. Okay, and as how many scatters, or how many points which we are going to just trying to have a plot, that will be 250. This is what we are going to show here. Okay, expected to show. Okay, so what I did, I filled the null values with 0. I am going to draw subplot. Okay, and status salary plot. One plot I'm going to prepare here. The first is the scatter plot, in which I'm taking salary and the status. Okay, these two. Then I'm going to set the x-axis, y-axis. Okay, salary status plot. I'm going to take here on y-axis. I'm taking not placed and the placed. Okay, not placed and the placed on y-axis I'm going to take, whether they are placed, whether they are not placed. This is what I'm going to take on the x labels. Size and the font, I already mentioned. Size you can change from your side. Font is something which you can take, again the same which I've already decided about what could be the font. Okay, then the y label I'm going not going to take anything. So finally, then plt dot title, title status of the salary, x label is the salary, legend and the show. Ultimately, what I need to show is here it is. This is what I need to show. Okay, so I need to show simply, if you want to go with very simple, if you want to go with very simple, if you don't want to have some different kind of interactive, so you can just draw sns dot scatter plot, and you can put x label and y label, and you can print like plt dot show. This could be over with the scatter plot. However, i have I have done a distinct. You can draw bar plot also for that. But however, bar plot, it doesn't make any sense, because the reason is here we are available with the salary. Here we are available the salary, and salary can have a different distribution. We have already seen about this is the distribution of the salary. Okay, so it's better to draw scatter plot only. The kind of plot which can be required for the salary purpose is a scatter plot only. Okay, so you can draw the scatter plot. In scatter plot, I did a change. That means I divided my xtix label into placed and not placed. This is what you can see: placed and not placed. This is how I done. Okay, so this is the salary. On x-axis you can see this is the complete salary. Okay, and here are you can mark what are your purple points, which you can see those who are plates, and these are having this salary, and those who are not placed, and this is like this is the salary status: placed and unplaced. Okay, so again I have divided my salary plot into not placed and placed. Two parts I have already divided here. So this is the structure which you are going to see. This is a plot, this is a scatter plot which has been mentioned here. Okay, so this is the salary. Okay, and placed and unplaced, what you are being going to see here. Okay, and the point here is, if they are in salary, what I did is not place null values. I've assigned a zero value. Fill any zero. Okay, data salary, fill any zero. So they will be having zero salary. No salary available with them. Only zero salary will be available. Okay, so you can see that those who are not placed, 67 values, they are just something wherever they are present, they are all just coming on this particular reference. And there is one person also, I guess, whatever be the cases, this is again a 0.0 something has been mentioned. Okay, so just divided the distribution of the scatter plot into two categories. One is a placed, one is a not a placed, and whoever are coming into the not placed thing, not placed thing. Okay, and having this zero salary or whatsoever, they are just coming on the same line, same reference line, you can see. Okay, so this is a scatter plot for it. If you want to draw a scatter plot just by simply like this, okay, if you are running the code from your side, okay, so just copy this code, copy, okay, and just paste it and do plt dot show and all these things. Just do this thing and just check out what kind of scatter plot you are getting from your side. Okay, you can do the same thing from your side without having separation in the ticks, y label ticks being placed and not placed. You can just simply draw a scatter plot between salary, between the salary and between the status. Okay, so status by salary I have defined. Status by salary. Okay, so this is the status, not place status. Okay, this is the salary, you can see all of them been coming in this particular range, and this is the point which you are going to see with respect to the salary. Okay, if you want to draw from your side, you can just copy this scatter plot. Okay, and just don't just do like this: sns dot scatter plot. Okay, and just print it, run it. Anyone did? Anyone executed? Anyone drawn a scatter plot? Chetan, have you
Yes,
printed
sir.
the scatter
Yeah,
plot?
yes.
Okay.
Yeah,
How?
yes, sir.
Okay. How it has been coming? Can you please show me? Can you show your screen? Let me stop sharing my screen. And can you please show? Can you share your screen and how the scatter plot has been coming? Because I'm not filtering here with the place and not place. Just a simple scatter plot between salary and your status. Anyone can show your screen?
But how can share?
You can share. Present now. Just go to present now and you can present.
Okay, okay.
Okay. Anyways, you can check out that how it has been visible. Okay, so just a simple scatter plot can be prepared. However, you can filter the scatter plot also. Now the next thing is data dot drop salary. After doing the visualization related to the salary, I have dropped this particular column because the salary doesn't keeps any importance for me. The next thing which
Is
I'm
it visible? Is it visible, sir?
uh, okay, let me stop sharing my screen. Okay, your screen is very much very blur, but can you show the plot? Just show the plot.
This?
This is my plot.
Okay.
Can you show your plot? No, no, not this thing. Don't scroll down. Up.
Uh, I think here.
No, this is my plot. I just need salary and status scatter plot. That's it. If you are coding with
Salary.
me.
I think this is
Can I
audible.
can I share it? Can I
Yeah, yeah,
share it?
sure, sure.
Okay.
Yes, yes.
Are you able to see?
Yes, I'm
This
able
is
to see.
the
Yes, yes. Yes, this
yeah.
is the plot.
This is
Okay, so this is
Salary.
placed. Okay, this is
yeah.
the placed and salary. You can see that between 20,000, 30,000, and 40, 50, and whatsoever. Okay, and here also see the salary in the plot which I have did mention to you. That is also like same thing, only 20, 30, and all these things. But the point is, but the point there was in my plot there has been mentioned exponential. They have mentioned exponential means 10 to the power 5 or something like that. Okay, so here you can see that those who are placed the status place, this is the salary has been coming under this particular range. Okay, or range of the salary. Okay, so you can see however you can filter this with the not placed and unplaced also. Here you can see the status with the placed thing. Okay, and I have drawn a plot in which there is a filtering between placed and unplaced also. Okay, so you can create the plots relevant accordingly. Okay, so now let me share my screen. Okay, so I have drawn my salary now, this column, because just a simple visualization is required, so that I did. So now the next thing is I need to draw the pie plot. I need to perform some different other visualizations also. Okay, and what could be the visualizations? I need to draw the pie plot. That will be like this: a status I'm going to take, and I need to create the classes of the status. Okay, two class. One is a place and place. I'm going to take the classes of my status. See, these all can be done with the simple visualizations also. Simple pie plot you can create, and this can also be done. Okay, and however the point is I'm going to take your plotly library. So pie colors, that is two colors I'm going to take, which has been mentioned, because I'm going to work out with the two values only. Okay. Prediction classes, predict classes, I'm going to assign a variable and taking value counts, data dot status dot value counts. Okay, how many values for your placed, how many values are for unplaced. Okay, this is what I'm going to take. Then figure, figure size you can give anything. I am given 17, 12, or whatsoever, 10, 15, or 10, 5, or whatever you want to give from your 10, 7, 15, 7, whatever you want to give, you can give. Then plt dot py, plt dot py. Okay, predicted classes, we are available with the two class. Okay, that means placed, not placed. Labels, I'm going to define them labels as yes and no from my side. Okay, not placed and unplaced. I'm going to assign the labels from my side, that is yes and no. Colors I'm going to take as a pie colors. Colors I have already defined two colors already. So this is what I'm going to take, two colors. Percentage distance, okay, that is your 0.65. This much percentage I can take. Shadow, there will be shadow in your there will be the spy plot will be going to let you know the shadow. Okay. And then the next thing is your next thing is your start angle, from where you want to start your pi plot, that is 90 degrees. Auto percentage, one till one percentage you can take the values, 1.1%. This is just a normal value. How much floating point percentage you can take. So it will be like 90, yeah, 90.5. Okay, so just only till one decimal places I'm going to take the percentage. Then text proportions, font size, what should be the font size? Okay, 30. What could be the color? Black. What could be the weight, that is board, and what could the family, or what could be the font, means which family it could be, like, so serif. It depends upon you. You need to check out how many family fonts are being available. Size you can define from your side, that's not a big issue. Color you can define from your side. Weight, either it is bold, you can decide none. If it would one, then there would not be bold, and all these things. Okay, you can define from your side. Okay. PLT dot, then select pixels. So all color white, size will be 30. Title I'm going to give it is higher, depends upon you what kind of title you can write from your side. Okay, center circle, there could be center coordinate also I'm going to define here. So PLT dot circle 0, 0. This is the center. Okay, 0, 0, center, and radius. Okay, so center coordinate and the radius 0.40. This is what I'm going to define. You can change it from your side. Okay, and then you can show. Okay, then plt.gcf add artist center circle. If I need to add a center or circle, I need to use these methods in my figure. GCF and center of the circle and all these things, this is what I need to use. Okay, so here is the graph. Here is the graph, pie plot, which you achieved. So 68.8% is yes, and 31.2% is no. That means not placed, and 68.8% is placed. This is what you got in a form of a pie plot. Interactive, highly interactive plot. Okay, this plot can also be prepared by just simple plt.py. This could also be prepared by this only. Okay, and then plt.show, not a big deal. However, we are just going to perform some enhancements, some additions in our plot. So that is why you can see that there is a center circle also been prepared. Color white is also been, I think, here. So color white is also been given here. Okay, so everything is been mentioned. So it depends upon you. If you got the skills on visualization, so you can create any kind of visualizations, better visualizations from your side. Just skills required, some practice required. What are the methods, what are the parameters which we need to use. Okay, and what else you can give here. So you can use it anything from your side. Okay, so this is how I have drawn your uh, this plot. Okay, this is pie plot. Okay, so you are using GCF or whatsoever. Okay, so plt.gcf, gcf is you're getting the current figure, get the current figure. Okay, so here I'm available with the current figure as your what, your pie plot, that is pi. Okay, so this is GCF getting your current figure, and add the axis to the current figure. Okay, so I added the axis, center of the circle I've added. So this is what you got. Okay, so this is your pie plot. Now the next thing is I'm just going to change the status. Okay, placed by 1 and not placed by 0. Okay, so just creating a dictionary map. Okay, map is also a dictionary basically. So either you can use label encoder here, you can use label encoder. If you are available with the two categories, then you can use label encoder here. So I need to import one more library from the sklearn, that is label encoder. However, it's not a mandatory, because I can just replace the values by 0 and 1 also by mapping, by using map function. Okay, so map is certainly like a dictionary also. So placed by 1 and not placed by 0. The point is I'm going to change into 0 and 1, because I can only train my model with numerical values. I can't train my model with these values. Okay, so change it to 0 and 1. Okay, so placed 1, not placed 0. I am serial number is not a mandatory thing. The one column इसको हम लेके चल रहे हैं साथ में serial number. I think it's better to drop it. We don't require the serial number. Drop. Gender also, male 1 and female 0. Just change this one also, 0 1. Just change this thing. Okay, this can also be changed. Now again, if I need to draw the plot, okay, related to the gender, so I can draw the count plot. Okay, so take sns.count plot, y.gender, y equal to data.gender. Okay, and palette equal to two colors. You can give the colors from your side. Okay, so palette is just a color. Okay, so you can give any colors. I have already defined the two colors. Gender is also of two category only, one is the male, one is the female. So you can take palette from your side. Palette, that means palette is a color. Okay, so either you can define colors from your side here, or either if you have predefined the colors, just use the list here. Okay, so the point is, if you want me to write, so I can just write like this. If you want to prepare a simple count plot, so sns dot count plot, you can do like this. And then you can take data, then you can take your gender. Okay, gender, then you can take your palette, like basically the palette which I used to use is hls. Okay, palette equal to hs, data equal to data. Obviously data will be equal to data only. Okay, no other from this column. I'm going to take from data only. Okay, so this is also you can prepare. Okay, count plot, a simple count plot will be showing here. Also the same thing is there, sns.count plot. Only the thing is you're setting the title, set title, student population by gender, setting the font size, y axis and everything, setting the y label as none, grid you are making as false. Okay, that means there will be no grid lines shown here. Okay, grid you are making false. Xticks labels, fnm, you are assigning xticks as fnm, and x label is count. Okay, this is what you are doing changes. Okay, so here you can see that, here you can see, here is the count. So previously if you draw a simple count plot, a simple count plot, if you draw by this thing, okay, your your count will come on y axis, and male and female, the gender will come on x axis. However, you did a change here in this plot. See, you can do any kind of application from your side. Okay, I've set the title, I've set my labels. What I did is on y ticks, I have prepared male and female. On y-ticks, on y I have taken male and female. In general, in common, y, f and m will come on x in general. But if you define from your side y-ticks, so they are coming on y-axis. Similarly, x label or the count, it has been coming on x. In general, this comes on y. In a sample count plot, this comes on y. Okay, and okay, so you have changed this thing. Okay, you have defined the font size also, so all these also, and edge font, that means what could be the font to be used here. Okay, and what could be the size, so you have already defined the font above. Okay, so this is the plot which you are going to see, student population by gender. Okay, now the next one is your cat plot, your category plot. Okay, so again, if I just want to prepare another plot, that is called as a cat plot. Okay, sns dot cat plot. Okay, now I'm the feature which I'm going to take here for the cat plot is again the status and the gender. This is what I'm going to take. Just let's see what happens. How many males and females got placed or unplaced whatsoever. Okay, so SNS dot cat plot. Okay, so what does this cat plot do? See, cat plot can do all kinds of functions. Okay, all kinds of functions. Uh, Basically, it can handle different kinds of plots which are available in the Seaborn. Okay, and what I know is cat plot can handle about 8 kind of different plots which are available in a Seaborn library. Okay, so basically cat plot will show you the frequency or the fraction or the percentage or the category available, whether we are having two category, whether we are having three category or whatsoever. So it will show you the frequencies or the fractions or the percentage or the values. So here I'm going to use the cat plot, and for cat plot let me show that male and female. If I just say is that how of them are placed and how of them are unplaced. So there could be a simple plot also with respect to it. There could be a simple plot like this. If I just take SNS dot count plot again. Okay, if I just take SNS dot count plot, just make SNS dot count plot. If I just take, okay, and if I just take data gender, okay, data gender. If I just take, and if I just take equal to hue equal to status. Just take hue equal to status, and then palette you can take anything. Palette color you can take anything. That is two variables, I guess. Two colors if you defined already, so just take two colors. If you don't want define, then take palette equal to this is my sample palette color which I take. Okay, so with respect to the hue, how many male and female, that means has been placed or not placed, it will give you the count plot. Then next is plt dot show. PLT dot show. This is what you can do. This could be a sample plot, a comparative plot basically for the gender and the status. This could be comparative plot. Okay, here also I have done something. Okay, here also I have done something. Male and female, how many with respect to the status, how many of them has been placed. So about we can see that more than 70%. Okay, you can see that this male tower. More than 70% of the males has been placed, and I think between 60 to 70% females are, are being placed. Okay, so here on Xtix you have taken male and female. Okay, and gender influence on stats, and this is the subtitle which you have given. Gender influence on the stat. This is the subtitle you have given. That's it. Okay, so you can draw this kind of plot also. How many placed and unplaced related to the male and female, and you can draw specific plot also related to the stats. Okay, so on y-axis status is there. Okay, and on x-axis gender is there. Okay, this is how you have plot. Similarly, I can take the distribution, data distribution. So distribution I can take like this. um, Draw a figure, plt figure, any size you can give, 18:6. Subplot I need to prepare. Title status distribution for ssc percentage. Okay, ssc exam status distribution. Grid I'm making as false, and whatever you can decide the grids and all these things from your side. You can take this thing as a reference also. So placed, again placed and not placed, placed and not placed. Okay, so what you can do, just a simple kd plot I need to prepare. Just a simple kd plot I need to prepare. Okay, and this kd plot I am taking data status equal to 1. That means those who are placed. X equal to ssp. That means on x axis I need to take only ssp. Okay, that means your senior school certificate. Okay, percentage for ssc. Shadow equal to true, whatever ax equal to x, fine. That means your ax equal to x means this is your axis which you have set. Okay, axis which you have set. Colors you can take from any side. Okay, colors, that two colors you can take from your side also, assign anything. Okay, and this is what text I have been mentioning. For text, what you need to write in your plot. So for placed, font properties again, serif, size 20, weight, bold, and color, you are taking all these things. So ax dot text. So ax is something this is been required to draw your plot. This is something required to draw your plot. Ax, Okay, basically if you are working with subplots, this is your grid, ax dot grid. Okay, so ax grid making false axis you can decide from your side. Okay, this is what you can give the access, and this is how you can define the text. Placed, I have defined the text. Not placed, I have defined the text, and just I'm drawing the KDE plot. Simple KDE plot can also be prepared, not like that key sir, this is looking a bit complex. It's not mandatory that you need to prepare the same thing from your side also. Simple KDE plot can also be prepared. Only the point is only the point is you have to just do the changes from your side. Whatever you want, you can do the changes. So this is, here I'm defining the text size, color, font, and everything I'm deciding. And the important thing which I need to draw is the KDE. That's it. KDE for placed also, equal to once. This is for placed, and this is for not placed. Okay, and SSCP, this is the X label I am setting, plt.x label. So this is, you can see. Okay, you can check out the graph for both of them, placed and not placed. This is the curve. There is overlapping also, overlapping between placed and not placed. There is an overlapping of the percentage. Okay, so this is the probability distribution. Okay, why probability distribution? Because the reason is these are in point, these are in point, so I can draw probability distribution for them. Previously also KDE I have drawn the probability distribution. I hope you have seen one more probability distribution we have drawn. Here it is, by salary. So if you are having a range of salary, if you are having a range of percentage, you can draw KDE plots. Okay, that will be beneficial. So here is a KDE plot for them also. Okay, now what I did is I prepared another variable, that is placed underscore group, placed underscore group, where I'm going to take those who are placed, and not placed group, that this is another group. Okay, and here I am taking what? Here I am taking what? That is your SSC only, SSC percentages for both of them, placed and not placed. Just take the SSC percentage only, and then I need to perform stats dot t test. Stats dot t. Now the actual operation came into the picture. Okay, here I need to perform some statistical test over it, statistical test operations. Okay, so stats, this comes under SciPy library. I have already included SciPy library in my code. Okay, so SciPy.stats t test. Okay, so it calculates the t test for the means of two independent samples of scores. T test I'm going to perform here. Okay, so again it's just like a statistical concept, t test, p test, or whatever the test you need to apply over it. So here the t test has been applied over the two independent sample scores. This is a two-sided test basically for null hypothesis. Okay, two-sided test for the null hypothesis, that two independent samples have identical average values or not. Okay, so if you know about what is null hypothesis in your statistics, so for that purpose only I am going to apply the t test here. Okay, so this is your t test. I'm applying for both of them. Two groups I have taken, one is the placed, one is the not placed. Okay, so here two-sided test for the null hypothesis, two independent samples, both are the samples are independent. Okay, that is why I'm taking parameters, two parameters, one is the placed, one is a not placed, with the percentage which they got in SSC. Okay, so two samples I'm going to take, and I'm going to perform a t test over it. That means it means of two independent samples of scores I'm going to apply the statistical test. Okay, the next test which I did apply is man and Whitney. Okay, this is another test which I applied, man and Whitney U test. Okay, or Wilcoxon ranked sum test. This is also another test which we are going to apply. Okay, and this test is basically used to analyze the difference between the two independent samples of original data. I need to check the difference between these two. Okay, so ये क्यों कर रहे हैं, why I'm going to perform all this statistical analysis? I need to check the difference, that okay, the person, the candidate, the student got this much percentage, whether they got how, what is the comparison? Okay, whether they got placed, whether they got unplaced with this much percentage. I need to draw some conclusion over it. That is why I'm performing the analysis. That is why I'm going to do this statistical test over it. Okay, so if I talk about this particular test, that is Wilcoxon test. Okay, it is used to analyze the difference between the two independent samples of original data. Okay, again, we are available with the two data samples here. As you are going to see that we are available with the two data samples. Okay, on these two data samples only we are going to perform the your observations, and both these data samples are independent of each other. Okay, they are independent of each other. Don't have any dependencies in these two. Okay, so here we need to perform the null hypothesis again. Again, the process is null hypothesis only. Okay, and the difference between the two samples has been taken. Okay, and this is what your U test belongs to. So T test and U test, the same thing. We are going to perform the analysis over the data samples taken with respect to your SSC percentage, whether the student placed, whether the student is unplaced. So you need to directly apply the formula. Not formula, it's a formula, or I just say it's a method, already predefined method available in stats. So just a general description I have given related to the statistics, that I need to use the null hypothesis technique. There are two different kind of tests are available. One is the T, one is a U. This is also called as a U test. Okay, two different tests are available. Basically I need to find a distribution. Okay, just find a difference, that okay, this much percentage, this much has been placed, this much percentage, this is not placed. Okay, just performing the test analysis. So T test and the U test. Okay, and just printing the results are like 4 point and 8.1. Okay, this is the result which we got after applying the test to these two. Okay.
Sir, what is the significance of both of these tests? How do we use those?
See, significance basically, as I told, they belongs to statistics. Statistical tests are being here. So distribution of the data we are going to check out, and only the significance is applying null hypothesis over it. Null hypothesis. Okay. So if you know about null hypothesis in statistics, what does this null hypothesis means? What does this null hypothesis mean? It is basically hypothesis. It is basically there is no significant difference being specified between the population and the observations, and what are the samples which you have taken to perform the analysis. Okay, so if I just define from my side what does this null hypothesis means, it is a statistical analysis. Okay, which tells you, you ask the question, sir, what is the importance, why are you doing it? Tells you that no statistical relationship and significance exist in a given set of observed samples or the values. Okay, between the two observed, is there any relationship exist or not? This is what I'm going to find out by applying these kind of two tests. So the question came, sir, why you applied T test, why you have applied U test? I am going to check, is there any relationship exist between these two or not. Ultimately they works under the principle of null hypothesis. In null hypothesis, it suggests that no statistical relationship and significance exists between the set of observations which you have taken, or the set of samples which you have taken. This is why we are going to apply the null hypothesis. Are you getting my point?
Sir,
Okay, so this is, that's the only reason I've applied these kind of two tests and I got these results. Okay, 4 and 8. Okay, there might be some what could be some point of relationship might be been available. So this has been showing, okay, by applying T test I got this score, by applying U test I got this score. Okay. After applying these hypotheses, these techniques, let me go for SSCB. SSCB, that means again central or other board exam, no? SSB, from where you have taken board exam or other central, this is taken. Okay, value counts I have done for them. I have converted them into 0 and 1, and then I have drawn the count plot for it. Okay, so this you can simply do from your side also, just drawing a sns dot count plot. Palette or the color you can take from anything. So just take ssb here and draw the count plot. Simple, very simple. Okay, setting title, x labels, y labels, x sticks, this you can do Okay, this just changing the values, this can be done from your side. Okay, just a simple count plot. So here it is, others and central. I think more of the students have more than I guess 100 students have taken central board and given SSB exam via central board, and remaining are the state board students. Okay, those who are others. Similarly, you can draw the category plot. Okay, again cat plot for the status and SS board. Okay, so category, and that means those who are placed, and if I need to show how many are placed and how many are not placed. Okay, so again you can show by SNS dot count plot also, SNS dot count plot. Okay, you can draw this thing also, like data I can take status. Data, if I just want to show status, okay, and I can take hue equal to ssb ssc underscore b. This is what hue I can take. So it will draw comparative plot for you. And then I can take palette I can take anything, any color I can take. Let me take HLS only, and data equal to data. That's it. This is what you need to do. So it will draw a comparative plot for you, and then plt dot show, plt dot show, done. Okay, but here just much more better visualizations. So I took ssc underscore b underscore plot, category plot. I am going to take status, and y on x-axis I am taking status, y-axis I am taking ssb, defining height and expert and kind. I need to draw bar plot for it. Okay, on x6 labels I'm taking others and the central. Okay, so this will be others and the central on x-axis. Okay, and title I'm going to give ssc influence on stats and whatever, just dimensions you are giving, so here I know that it is hard to remember. Obviously it's hard to remember. Only the point is, if you are either you are available with your the kind of methods, what variables, what arguments I need to give, it has been available with you, so you can just substitute all the values. And if you are available with this particular block of code, just put a substitution from your side, what is required, what is not required, that's it only. But this will also make a sense, count plot will also make a sense, no worries. Here you are drawing a bar plot. In count plot also bar will be plotted, no worries. In count plot also bar or towers will be plotted. A comparative plot will be there. Again, if you want, you can draw, I have already mentioned you the code, you can draw the count plot also. Okay, so now the next thing is your if I need to draw what, your kd plot, kd. So again, just take kd. Okay, hsc percentage you can take. Data status 1, I have already explained this code above. Data percentage just means placed as 1, and placed and not placed. Okay, just take placed and not placed with hsc percentage. Previously we done the same thing with ssc percentage. Now you can do the same task with HSC percentage. Okay, so same thing available. Status distribution of higher secondary, grid falls. Okay, I'm defining the text for placed. This is how you can define the text for the place. This is how you can define the text for not placed. Okay, this is both you can define, and you can apply the KD plot over it. Previously you did for the SSC, now you're doing for HSC for the percentage. That's it. And just print the mean for 1 and 0. That means for placed, and for not placed, just draw the mean, print the mean. Okay, so you can see that placed 69%, 58% are not placed. If we go with respect to the HSC percentage, okay, calculate the mean value of them. And here is your KD plot. Not placed, okay, placed, and here is your overlapping between these two. Overlapping percentage basically. This is the overlap percentage. That means these people are having this much percentage. Okay, so this is your HSC also. Okay, now the next thing, I guess this code doesn't make any importance or sense for you, bootstrapping and something, because I need to draw just a histogram. I guess this doesn't make any sense for you. Let's proceed ahead. Okay, let's proceed ahead. Hmm. Now the next thing is, I'm just skipping that particular sense of code because that it's not been required as such. Now the next set of code is your again HSCB board. I'm again converting it into your mapping 0 to 0 and 1. Central board I'm taking 1, others I'm taking 0, and drawing your count plot for them. Okay, drawing the count plot. Here I'm taking on x-axis HSCB, okay, and color I'm taking HLS, any color set, two colors, or whatever you define already, you're just taking the colors from their side. Okay, just draw the count plot, just simply remaining all these lines. What is the title we need to set, what is the X label we need to set, grid we are making false, X sticks what you need to set. This is something I hope you believe that okay sir, this is something looking complex or whatsoever, but actually once you are available with all these title and X labels, so you can write from your side also. Okay, if you are available with the code, you can do the changes. If to be very simple, I have already told you how to use simple, how to use it as a simple, just write sns.conplot and just draw it, that's it. This can also make the things simple. But if you want to have some highly interactive, if you want to have some settings from your side, okay, settings from your side, so you can define the xticks and all these things, okay, and labels, and you can define from your side, you can give the colors, you can give the font size from your side, and you can draw the plots. Okay, so this is HSC. Okay, and here I just basically skip this particular bootstrap code because I hope it's not been required, because this particular code is strictly based upon your statistics. Okay, statistical code. Okay, so TQDM, I've already told about this library, that if you want to show the progress of some download or upload or whatsoever, that is why you are using TQDM. This is an Arabic word. Okay, and then you are defining a method that is called as bootstrap. You're taking data columns, that is numerical values, data column 2 again numerical value, how many samples you are going to take for the bootstrapping technique. This is what, this is your mean value, this is your confidence level. Okay, these variables you are taking. So you're taking two values to perform the analysis, the column 1 and column 2, you're taking two techniques. Okay, for I in TQDM range of boot IT, that means your 1000 samples. After those, you're taking about 1000 samples. You're applying for loop here. You're taking the sample number 1, you're taking the sample number 2, you're taking two samples. Okay, then you are going to perform statistic over it. Boot underscore data append statistic. So your boot data is already an empty list. Okay, so you need to perform some statistical operation over it and creating a data frame. Okay, so this is left quantile, right quantile, and left and right quantile. You're going to take these values, and these your standard deviation, mean, all these values for both the samples you are taking. Okay, and then drawing the visualizations related to it. So I could have explained, I just give just a sample description, but this quite be a bit complex for you to understand. Okay, so that's why I haven't taken, because I'm, as I perform the t test and a u test above. Similarly, p test and a t test which I have taken done above. Similarly, this is a kind of a test which I am going to perform over HSC values also. Okay, by taking these two samples, there also I took two samples. One is for placed and one is for not placed. Two samples I did take took from my side. Okay, so this is a histogram has been created. However, you can also apply the t test and u test also here, here also, and do the same thing. So this is just a test only which has been applied. How many values are coming, that means I have taken a sample, I have taken two columns. Okay, one is placed, one is not placed. I've taken the sample values and I've taken the mean, statistical mean of that. Okay, and confidence value I'm taking as 98%. This is a threshold value basically. Okay, and then I'm applying a for loop here and giving the sample values. Okay, these two sample values I've already given. Okay, and then I'm creating a statistical operation. Statistic, just apply a static method. Okay, and calculating the left count and the right count, and this is the overall count by left and right. Okay, that's it. Okay, and just plotting the mean values and standard deviation for both p1 and the p2. Okay, and calculating the minimum p value. Okay, p value. So that's why I tell you, no, p test, t test, u test. So you can say that, sir, this is a p test, this is an complete, there is no method actually, if I just say what is the method for the p, but there is a complete algorithm mentioned to apply the p test. Okay, so this is what p test I have applied. And the same thing, just to check, to perform an analysis whether this status placed or unplaced are having similar data type data or not, what is the distribution of data in these two. Okay, so this is how I drawn the histogram. Okay, after an analysis. So just not to make the things complex, just to keep the things simple, I skipped this code. But however, now the code is already available with you, you are going to run this codes. So just a simple description I have given you. Okay, so just applying this test p value, I need to calculate the p value or the p score for it. Okay, probability score, previous also in this a t test and a u test also you did the same thing. Okay, different kind of tests which you have applied. Okay, I guess where is the test. Okay, there are tests which you have seen already. Okay, same thing, yeah, here it is, t test and the u test. Here already methods are available. And for p value calculation, I'm not using any direct method. This is the algorithm only I'm going to apply for calculation of the p value. So here is the histogram. Okay, so again let me stop the recording and restart.